Okay, in today's video, we're going to use the quadratic formula to solve quadratic equations. Before we solve quadratic equations, we need to make sure of two things. First, we need to make sure that all of our equations are equal to the number 0. And if you look at our example 1 here, right now it's equal to 11. So before doing any A, B, and C stuff, let's bring that 11 over to make it negative 11. Now that it's equal to 0, it's in standard form of x squared minus 10x minus 11. I can go ahead and identify what A and B and C are. The number in front of x squared is a 1, so there's your value of A. In front of x is negative 10, there's the value of B. And C, the constant, is negative 11. In my personal preference, I think finding the discriminant value first will aid in being successful with using the quadratic formula. So I'm going to go ahead and plug everything into b squared minus 4ac. And typing that into the calculator, negative 10 squared minus 4 times 1 times negative 11 is going to yield the value of 144. So what this tells me is I'm going to take the 144 and I'm going to put that underneath the square root sign in the quadratic equation. So here you'll see the 144 underneath the square root sign. The other thing I want to point out is in the quadratic equation it tells us to do the opposite of b. So if b right now is negative 10, the opposite of that is positive 10. Also, on the bottom, 2 times a. The a value right now is 1, so we'll do 2 times 1 in the equation. Clean this equation up. Now we're going to see that x is equal to 10 plus or minus 12 because the square root of 144 is 12. This gives us two equations to solve. One of our equations is, let's do 10 plus 12, gives us the value of 22. Divide by 2. 22 divided by 2 gives us an answer, or one of the solutions, of 11. Going back in, doing the subtraction. 10 minus 12 will give us negative 2, and when you take negative 2 and divide it by 2, we get the second solution of negative 1. So this gives us two really nice rational roots out of this. Taking another example here, now we have x squared plus 8x plus 16. We notice that the equation is already equal to the number 0, so I can go ahead and start by identifying what a, b, and c are. This gives us a of 1, b is 8, and c is 16. Again, I'm going to stick with finding the discriminant value of b squared minus 4ac. Plugging in what we know, 8 squared minus 4 times 1 times 16 will give us a value of 0. So this time underneath the square root, we'll put the number 0. For the rest of the equation, we have negative 8, given that that's the opposite of b, plus or minus the square root of 0, all over that a number of 2 times 1, which then will give us negative b, or in other words, negative 8, plus or minus the square root of 0 is going to stay 0. And what you should find here is that whether I do negative 8 plus 0 or if I do negative 8 minus 0, it's still going to keep the numerator as a negative 8. So we're only going to have one solution here, and that's negative 8 divided by 2, or negative 4. So nice answer here with one rational root. The last example we had two really nice answers with rational solutions. But the best part about the quadratic formula is that we're able to figure out what those irrational answers are. The ones that we can't really write as really nice fractions. And that's what we're going to look at here for the next few examples. So I double check, make sure my equation is equal to 0. We can check that box. Identify A, B, and C. Take the A, B, and C, plug it into b squared minus 4ac. 6 squared minus 4 times 2 times negative 7 is going to give us 92. So there, once again, that's the number that we're going to put underneath the square root sign in the quadratic equation. Plugging in, we got the opposite of b. b right now is 6, so opposite of that is negative 6, plus or minus the square root of 92, all over 2 times a. So a again is 2. And clean up what we know. Well, the only thing I can clean up so far is the 2 times 2 on the bottom. So we get negative 6 plus or minus the square root of 92 all over 4. And what I want to turn my attention to is I really want to focus on the square root of 92. Because sometimes we might have to break that radical down. Think back to using factor trees, or what's the largest perfect square that divides into 92? So off to the side, double check. The largest perfect square that's going to divide into 92 is going to be the number 4. So you can rewrite 92 as 4 times 23. But the square root of 4 is 2, so we get to take the 2 out front, leave the square root of 23 in, and this right here, the 2 root 23 is what you're going to replace the square root of 92 with, which gives us negative 6 plus or minus 2 root 23 all over 2. And you might think that we're finished here, but the last thing you got to be careful with is let's look at all these numbers on the outside of the square root here. Do they have a common factor? Is there something that we can divide out of it? I know that they're all even, so they're definitely divisible by 2. If I take negative 6 and divide it by 2, we get negative 3. Cancel out the 2 from the coefficient of the square root of 23. And then lastly, the bottom, 4 divided by 2 gives us 2. So then we can say this is the simplified solution here. We got negative 3 plus or minus the square root of 23 all over 2. Let's take a look at one that maybe doesn't require as much work. So 3a is definitely equal to 0. Got the a value of 3, b of 5, and c is 1. Finding that discriminant value, get 5 squared minus 4 times 3 times 1, which gives us 13. So just like the 92, 13 is going to be the number that goes underneath the square root. And continue with the rest of the quadratic formula. Since the opposite of b, we got 5, so the opposite of that is negative 5, plus or minus the square root of 13, all over 2 times the a value of 3. What we see here is I don't have to break down the square root of 13. It's as simplified as it can get. So I can say that, here's my solution, negative 5 plus or minus the square root of 13, all over 16. The final type equation that we're going to look at is what happens when we get complex solutions. Here we're going to get a complex solution. We don't know that that's going to happen until we start solving with the quadratic formula, so we keep our steps the same. Is the equation equal to 0 right now? Right now it's equal to negative 10, so we're going to add the 10 over to get x squared minus 6x plus 10. Identify the a, b, and the c values. Take those numbers, plug it into the discriminant. Use the calculator to figure out what negative 6 squared minus 4 times 1 times 10 is. That gives us the value of negative 4, and since my discriminant here is a negative, I know for a fact that I'm going to have complex solutions. Go ahead and fill in the rest of the quadratic formula. The opposite of the b value, so opposite of negative 6 is 6, plus or minus the square root of negative 4, all over 2 times our a value of 1. So I know I got a negative number underneath my square root, so I'm going to take the negative symbol out, put the I out front. Gives us 6 plus or minus I root 4 all over 2. But what's special about the square root of 4 is that's also a perfect square. We can simplify it, which will give us 6 plus or minus 2i over 2. Now we look at what we have on the tops and the bottom. Everything's even, so we can reduce down our numbers. 6 divided by 2 will give us a 3. And then the 2's will cancel out of the 2 i's. And now we have plus or minus I. And that's our complex solution for this particular quadratic. And not every quadratic that we have with complex solutions will have the denominator cancel out, so we need to be careful with it. So going on to the next one. Hey look, 4a is also equal to 0. So we can go ahead and steal our a, b's, and c's. A of 3, b of 5, and c is 4. And once again, plug everything into our discriminant to see what its value is. To get 5 squared minus 4 times 3 times another 4, our value now is negative 23. So we're going to put this number underneath the square root in the quadratic formula. The opposite of our b value, so negative 5 plus or minus the square root of negative 23 all over 2 times our a value of 3. We can go ahead and take the negative sign out, put the I out front of the root. We can also multiply the 2 times 3 on the bottom to get 6. And if you look at the negative 5, the 6, and the I, there is nothing in common that I can cancel out. So then we can say our solution is negative 5 plus or minus I root 23 all over 6. So there are several examples to show you how to use the quadratic formula to solve any quadratic equation.